right, parallelograms. We've got a parallelogram in our picture. We know that because it says so right there. And we're supposed to complete each statement. So the first one says KN. So that side right there is congruent to ML. And those are congruent because they're opposite sides. Number 9, angle NML. NML. All right, that's that whole angle right there is congruent to that opposite angle. Man, oh man, oh man, I'm struggling. Opposite angle over there, so we're going to call that one angle NKL. If you switch the order of those letters, that's just fine. Number 10, MX. So if I look at my picture, where's MX? All right, that's right there. I'm going to use 2 marks right there. And MX is half of that diagonal, so the other half of that diagonal right there. Because remember, in parallelograms, diagonals get bisected. So that diagonal is bisected, which means it's congruent to KX. Angle 1, so we got that angle right there, that little angle right there is congruent to, and we're thinking, are the angles bisected? No, they're not. But we do have parallel sides right there since it's parallelogram, so it's congruent to that alternate interior angle, angle 5. KNM, now no fancy marks for this one, but KNM, that angle right up there is supplementary to, and you've got 2 choices here. We could talk about angle K, NKL, or this angle up here, NML. So I'm going to go angle NKL because those consecutive, woo, that word almost got away from me. Those consecutive angles are supplementary. So we can talk about NKL or we can talk about angle NML. And finally, we got triangle MLN. All right, so let's trace this so we can actually see it. MLN. All right, that big old triangle up there. Since I start with that angle M, I know I want to start with this K right down here, so I'm going to go triangle K. And then from M, we go to L, so I know I want to go up here to N, because 2 and 6 are congruent, because those are alternate interior angles. And then I'm going to slide on down to that last one, L. So I've got K, N, L. Using properties of parallelograms to solve for variables. All right, we've got sides and we've got angles here. Those little circles right there, had a lot of people think those were zeros on a test. Those are degree markers. So I'm going to start with the C's, since those are sides. 4C plus 5 should equal 7C minus 13. Algebra, however you're going to algebra. I'm going to go 18 equals 3C because I like keeping things positive. And so C equals 6. Just find the value of the variable. Done. All right, now D, those opposite angles are congruent. So I know 6D plus 9 is equal to 10D minus 27. Again, I'm going to keep it positive. So 4D equals 36. And D equals 9. All right, so we got D is 9 and C is 6. Number 15, again, I've got those opposite angles right there. Now, if you set up that equation, you're going to notice real quick, you've got 3G and 4 and 9H. Not going to help us. We got 1G, 1H, one equation. Can't solve for both. So instead, what I'm going to do is I'm going to use this angle right up here and this angle right up here. Since those are consecutive angles, those angles have to be supplementary. So 6G minus 14, I'm saying equals, but that's not what supplementary means. Supplementary means I can add them together and they should equal 180. That's because they're consecutive angles, parallel lines, transversal, blah, blah, blah. I'm going to combine my like terms, 6G and 3G, 9G, negative, positive, minus 9, equals 180. So 9G equals 189. So G is equal to, I know, this is a problem I could do in my head on a good day, but G is 21, right there. So G is 21. Once I know what G is, I can use that to find one of these angles. Doesn't matter which one I find. I'm gonna go ahead and find that 3G plus 5. So 3 times 21 plus 5, that's 68. So this angle right down here is equal to 68, which means this angle up here, that opposite angle, is also 68. So now I know 9H minus 4 equals 68. 9H equals 72. And so H equals 8. So we've got H and G. All right, 2 more problems here. We can see that this parallelogram got cut up a little bit. I'm going to go ahead and say 3p plus 2 and 6p minus 10 are those opposite sides. So I know that 6p minus 10 is going to equal 3p plus 2. So 3p is going to equal 12, and p is going to equal 4. Algebra. And furthermore, these two parts of the diagonal, since diagonals are bisect each other, I know that 5q minus 11 is equal to 3q plus 5. So 2q is equal to 16, or q is equal to 8. All right, so we got 4 and 8. And then finally, for the last one, we've got opposite sides. The letters line up nicely, so I'm going to go ahead and I can just solve these. We've got 5e plus 14 equals 12e minus 42. 7e equals 52, 56 right there. And so e equals 8. And the last one, 2t plus 25 equals 8t plus 7. 6t equals 18. T equals 3. Not a good algebra there. All right, we got a long run of problems here. Given the picture, given the information, is it possible to prove a quadrilateral is a parallelogram from the given information? If it's not possible, write none. If it is possible, then we're supposed to choose from one of these 3 options here. So I'm going to look, and I've got a lot to write and then erase because every problem starts over. So it starts off by saying FA is congruent to EB. All right, that's a good start because we got opposite sides that are congruent. And then furthermore, FA is parallel to EB. All right, a lot of good information from parallel lines. So because I've got that parallel and congruent, both things about one set of lines, it is enough to say it is a parallelogram, and that parallelogram is going to be, let's make sure I get these letters right, FABE. You can just kind of go crazy with that parallelogram sketch in front of the shape. Number 19. So I'm going to clear the drawing like that. All right, now it says FD. Okay, so I'm going to go over here. FD, and I want to make sure I'm talking about that whole thing, so just lock that away. AC, that whole thing right there. And AF, right there. And CD, so that whole thing right there. Yep, there we go. We've got 2 sets of opposite sides are congruent. That is enough. And I want to talk about that big parallelogram here, FACD. So parallelogram, whoa, things got a little dicey there at the end. FACD. All right, opposite sides congruent. All right, third one. I'll get those numbers up there. When we look at this, we've got some parallel sides. So FA is parallel to EB. Cool, cool, cool. And then DC, double O. All right, DC is parallel to E. Oh, no. So now, notice we've got 3 parallel lines. They're all parallel to each other. That's great, but that doesn't get me a parallelogram because I need something about those other sides, or I need some sides to be congruent with each other. So unfortunately, this answer is none. Go ahead and clear off those marks. Things got crazy there. There we go. Oh man. All right. Sorry about this. There we go. Okay. Number 21. Angle 1 and 3. So I'm going to go ahead and mark angle 1, angle 3. Now, as soon as I do that, it's not written down here, but those congruent angles right there, those are alternate interior angles. So that gives me some parallel lines. That's good stuff. All right, and the second thing that this tells me is that angle 2 is congruent to angle 4. Oh man, more alternate interior angles. All right, so we got some parallel lines here. This right here is telling me that I've got alternate sides that are both parallel. That is a parallelogram. So right here, we do want to say parallelogram, F-A-B-E. F-A-B-E. All right. In our 22, we've got, let's see if I can do this without messing everything up this time. There we go. All right, we've got FD parallel to AC, and EB parallel to DC over there. Oh, wait. Because of where I put this mark, my mind immediately said no. But we want to make sure that these lines right here, they also mean these lines over here. They go all the way through. So if we look at just this little parallelogram over here on the side, we've got opposite sides parallel, which is enough to say it is a parallelogram. And that one we're going to call BCDE, BCDE. And finally, number 23. Now I'm going to clear off my drawing first. Ooh. There we go. We've got FG is congruent to GB. All right, let's see. FG, okay, that's right here. And GB, oh, we've got some diagonals. All right, AG is congruent to GE. Yep, we've got 2 diagonals that do bisect each other. So yes, we've got a parallelogram, and it's at FABE again. The last set, as the announcements pop down. Decide whether you're given enough information. Decide if a quadrilateral is parallelogram. So we're starting with the quadrilateral, so we don't have to worry. These are 4 sides. They all, they all touch all the way around, all that kind of good stuff. Opposite sides are parallel. Yep. That is enough. Opposite sides are congruent. Yes, opposite sides are congruent. That's cool. 2 pairs of consecutive sides are congruent. No. Now, if you're looking for a counterexample here, the classic is kind of a diamond shape, or what we'll come to call a kite. So that's a no. We've got 2 pairs of consecutive angles are congruent. 2 pairs of consecutive angles are congruent. I mean, consecutive angles are congruent. That's an immediate no, right? We want those consecutive angles to be supplementary, or opposite angles to be congruent. Diagonals are congruent. No, I want the diagonals to bisect. There we go. Diagonals bisect. That's a big yes. And then all 4 sides congruent. That's fine, because the opposite sides would be congruent if all 4 sides are congruent. And then finally, we've got consecutive angles are supplementary. That's what we want for those consecutive angles. you.